Hi everybody. Today we're going to talk about Descriptive Statistics Part 2 and Characterizing Data. Alright, just to talk a little bit about our learning objectives today, we're going to define ways to characterize data and display information in a way that is clear, concise, and purposeful. And I'll get into that in a minute, a little bit more. We're going to identify common diagrams for characterizing data. Some of those common diagrams are pictograms, dot plots, bar charts, histograms, frequency polygons, time series graphs, pie charts, and lastly Pareto Charts or Pareto Charts. We're going to also talk about rules of thumb for tables as well. And before we get into that, I'm going to take you to a different screen here and show you the Excel sheet that you can download and where you can find examples of all of these charts that I have in the lectures that are easy for you to work through and actually see how I created them. And the other side of this is please make sure you download the PDF of this lecture so you can follow along in case the video is out of focus in any way. So if you look and download the Excel file, what you'll find is you'll find this file here, and at the bottom you can see all the different charts that you can look up and be able to reference and see how they were made in the slides. Okay, pie charts and then the Pareto chart there at the end. Alright, so that's in the Excel file. Now we're going to go back to the slides as well and start walking through the different parts of characterizing data. Alright, I wanted to quickly recap so that everybody understood where we were. In this course so far, what we've done is we have conceptualized and operationalized data. We've looked at types of data, sources of data as well. We've looked at graphical techniques for organizing data or patterns in data and how we understand patterns. We've looked at measuring central tendency, the mean, the median, the mode. And now we're going to look at ways of characterizing those data and displaying them in a way that people can understand that is clear and concise and it uses purpose in the process. All right, and that's what I've said here as well. We really want you to be able to understand that each chart has a different use and it affects, it should have a purpose as well. It has a reason why you're using it. We'll talk about that today. But also, it's important to make sure that the information is clear and concise. We'll talk about that a little bit. All right, so to start off, an example of that's very basic that uses images that is very approachable for people to understand your information and your data are pictograms, right? It's basically using pictures to represent data. Here we have, on the upper part, we have number of children that are going to school and traveling to school, and we have different representations that help people understand quickly what the y-axis pertains to. Okay, same with treats or candy in school. The number, maybe not in school, but at home or with people eating candy. The number of different Smarties that are being eaten can be shown by color and then broken down by frequency. Different ways to represent information. Sometimes we have pictograms that have images of people or houses, for example, for representing the number of houses, things like that. Pretty straightforward, easy to use. They've been around for a long time. You could argue that some of these pictograms, representations of numbers, have been used in in early cave drawings or even in the Egyptian times as well. All right, dot plots are another way that we show frequency or observations and the number of observations. And we plot, of course, on an X and Y axis. In this case, I'm using an example to show you the multiple times the data occur for the same value. In other words, how many data occur, for example, on each day. The lecture M4, the module number 4, example of that was safety violations observed over a 25-day period. So we knew which day and we knew how many violations were observed. So in a typical dot plot, what you also might see in this case is you might see that if this is 10 dots, that you would have the dots filled in below it. Right? So you would see the dots actually lined up. And that's how you get a dot plot. Okay, but in this case, we're only seeing the total number of frequency or observations of violations. All right, bar charts are probably pretty typical of what you're going to see a lot. Data are represented in the form of vertical or horizontal bars of equal width. Okay, they're typically equal width. A column chart often is what you see going vertically, and a bar chart is often what we call going horizontally. I'll show you examples of that. The height and the length of the bars vary depending on the data quantity that they're representing, right? So the frequency or the number of observations that you have. In this case, we're talking about many different types of bar charts that you might see: single bars, multiple bars, component bars. And I'll give you an example of that in a minute, but basically we have multiple data that we're observing along the x-axis, and so we can stack it. Sometimes we call it stacked bar charts. And then often what you'll see in scheduling is a Gantt chart, right, which is a form of bar chart. And then we can also do what's called back-to-back. I won't show you an example of that today here. All right, so here's an example of a column chart, bar chart example. So we have vertical bars that are coming up to show the number of violations of that same example of safety violations over a 25-day period. So along the x-axis you have the days, and along the y-axis you have the number of violations. And you see, based on the height of the bar, how many violations there are. Here we have the horizontal bar chart instead of the column chart on the previous one. Don't get confused because they're often just called bar charts, but there is a difference between the columns that might go vertically or the bars that might go horizontally. Same example again, but in this case we flipped the x and the y-axis because of the size of the number of days, and we couldn't fit it in, so it's actually flipped, and we see the number of violations now running along the x-axis, and we see the days, and you'll notice that the integers of the days from the previous column chart, we had each single day. Now we're skipping because of the size of this, and we're skipping days, and every other day we're seeing presented on there. When we have multiple bars, we can actually add in these bars next to each other. What I've done here is I've taken that example from Module 4 on safety violations, and I've added another column of information. I've said how many man-hours were lost. All right? That might be a typical situation you see in construction. Not only the number of violations, we want to know, did we lose time on the job? Right? Are we actually losing that those man-hours? So I've added that in here. Those correspond to each day as well. Right? Can you see how they correspond to each day? And then we can place them with multiple bars or multiple columns, as we discussed before. The language would be along each day. And we can start to compare and see some kind of comparison. When we have a lot of violations, we might see that the number of man-hours that we've lost for that day have gone up. That's what we would expect. In that same example again, but in this case we're talking about component bar charts. So what we've done is we've taken the lost hours here, which are in red if you can't see it very well, and we've added it onto the top of each column. All right? So it represents a number. It's taking that column and it's increasing the size. So typically when you do this situation, when you actually stack the bar chart, they have to have a strong relationship to each other. You wouldn't want to do this for items that have a completely different relationship and that it doesn't really matter. So this is one way of showing information. It's concise, it's clear, and it's interesting, and you can start to see a real strength when you get to lost hours and the number of violations combined. Okay, histograms are typically similar to a bar chart, but we're using them with group data, for example, or we're looking at relative frequency. So in this case, we're looking at a frequency of the numbers of concrete test strengths. Right. This was another example back from Lecture 4 that I'm going to keep using because it makes a lot of sense within the industry. In this case, we saw that what we did was we took the 50 observations of concrete strength tests and we placed them into groups. Okay, we placed them into 7 groups, And these are the 7 groups that we have here, or classes is what we call them. All right, and in this case, we can see a histogram. What's different about this than the bar chart is that you actually have each group touch it, because the data that sit within these are continuous between the different classes, but we have these groups touching. All right, and that's the big difference. When they're grouped and you have classes, the classes have an upper boundary that is the lower boundary, basically, of the next class. So you need to show them, and in a histogram, it will line them up this way. It also helps us to start to see the trends and the frequency. If you remember from previous lectures, we talked about this set of data being bimodal, right? So this is a modal class, and this is a modal class, where we have, each of these have 10 observations, and so they both rise to the top as being the most frequent observation in that class, in those classes. Okay? All right, now we can also use histograms to show relative frequency or percentage of frequency. So before we had counts of how many observations fit within each class. Now we're seeing actually the percentage. So the y-axis has changed. Before the y-axis was the actual frequency, it was the number of counts of test strengths that fit within this class or this class. But now we actually see that these classes across the entire group have a frequency or a percentage. This class is about 8% of the total observations. This class is getting up towards 15, this one towards 20. It looks the same in its central tendency, but in its dispersion, but at the same time, it's different information that we're seeing, and it's interesting to see how each class fits within the percentage overall. And we'll talk about how to reorganize these in a minute so that it makes sense. We can also place lines on top of that, a polygon that allows us to also accentuate, right, the form of that frequency, right? What I've done here is I took the previous data, so don't get confused. It's still the same strength classes, but I changed the information because I wanted to emphasize how this central class we might have a nice central tendency on this set of data. Before, remember, this was higher, this was lower, and this was higher to be the same, those two. But in this case, I've gone ahead and changed the data in the actual data set so that we could look and see a strong central tendency. But a frequency polygon is where we actually place the data points on top of the shape, right, and we connect those dots. Each one of these numbers represents the frequency number for each bar. We can also do, over time, what's called a time series graph. And this allows us to see the number of violations. We're going back to the safety example and the safety violations. We can see the number of violations over the days, right? So these are the days that we have been collecting and the observations, right? And on each day from 0 to 25 days, we have a number of violations that we're seeing. So we can start to see how on certain days it starts to spike, or we start to have a trough, right? We start to have less observations of safety violations in this case. It's a nice kind of timeline, and it breaks it out nicely for us. All right, another very common way that we're going to display information, that you can work with information, is through pie charts. That same information on violations, what we did was we broke it down by frequency, and then we look as a whole how often and what percentage of the total those observations are. So, for example, 6 violations, days that had 6 violations occurred 16% of the total data set. We start to see that the higher violations, like 10, 11, and 12, those actually have quite a high percentage of the total data set if we look at the number of days that we had 10 violations or 11 violations. Okay? We can see this in a simple format. That's what this is called, as a simple format. Or we can look at it as a 3-dimensional format. You start to see that it becomes 3-dimensional. Often people respond better to seeing some depth to it, and you can really work out how the information is presented in a nice way so that they can understand, but maybe the information is actually put on top of here. And if you go into the Excel sheet, you can play with these settings and see which one you think conveys the best information. An example of exploded would be, if we're interested in seeing how possibly those 11 broke down, sometimes what you'll see is you'll see the chart that has another pie chart with it that breaks down those 11 into, percentages of the 11 violations and some kind of characteristic about them. You'll see these types of exploded pie charts as well that are very effective. But again, this was based on that safety example. We're using the number of violations and what percentage of the total those violations represent. Okay, and Pareto charts or Pareto charts, they're a little different than the bar charts or the histograms. In this case, we're using that same example where we had the 50 strength tests of concrete tubes, and we grouped them into 7 classes. But before, you saw that all of the classes were sequential. What the Pareto chart typically does is it shifts and skews the data and brings classes that have the highest number of observations first, right? And this line here is showing you, it is based on the percentage here, the frequency, so you can see if the line jumps really high, how these classes that have been listed first represent a percentage of the total, right? So it's a nice way to visually show a number of pieces of information. Not only the number of observations, how many strength tests fit within this class. And here we see 20 strength tests were between 38 and 40 of our unit. But if we line those up from greatest to smallest, we can see also where those classes, where we have the most emphasis of those types of tests, right? And it's important to know that because we want to see quickly and visually which classes stand out the most, for example, right? In this case, we want to see, are we getting the right strength test after a certain amount of days within classes that would allow us to fit the specifications and be correct, and know that we have good and strong concrete. All right, I want to show you a quick example from some of my research on the differences in data and when we chart them, how you can see a lot of different information. There's a lot of information on this slide. Here you can see averages across different groups, right? We looked at properties that were renovated, they were new versus senior or non-senior. We had developments across the x-axis. What this shows us is the amount of expected or estimated, or in some ways simulated, energy use that we had predicted before we actually did the work. Okay, so very tightly ordered dots in this case. We thought that for development 2, for example, we'd have a very close set of energy use observations. Well, once we actually went and we looked at the actual energy use, what we saw is that those dots are not clustered. They're not tight together. So they're all over the place. So what this shows us is the level of variability that we see within this data, right? And it's important to see how the differences between the two. This is what we expected to see, we were hoping to see, but then graphically we can show people this is what it ended up looking like, right? So now we need to understand why that variability is happening, and that's what we'll get into later in the class, is to try to show any correlates between actual energy use and what we had designed the facility to do, right? But then we can also see means, we can see averages across the group and how far these values are sitting off of the average values. So there's a lot of information we can interpret from these charts. But there's a lot of power that you can use in these graphics, and they really help. Okay, here we're talking about rules of thumb for data. This comes from Myers and Tufte. 6 rules of thumb, basic rules of thumb. Show the data above all else. Make sure that the data are in the tables, they're in the charts. It's something that people can easily see. Focus your attention on comparisons. It's always good to have comparisons so people can understand the important pieces of information and comparing them, right? And that's what you're trying to focus down on in your data. Again, clear, concise, and with purpose. Maximize the data-inc ratio. All right, so if you have data, make sure that you're, instead of using a lot of text, you're using the data and showing in these charts and in these tables, how they can be used. Resist a lot of chart junk. It's a term just meaning a lot of extraneous information and other information or shapes or ways that you're presenting the information that might not really get to the point of what you're trying to say. You should integrate your graphics and text. Don't segregate them. So if you have graphics and you have text, don't have your text over to one side and your graphics on another side. Try to put them together. Make it very straightforward so people can understand exactly what you're trying to show. Here's a great example of, and I know it's blurry on the slide here, but this is a representation of Napoleon's march to Moscow. So Napoleon starts marching here, and that distance right there is the size of his army. It's shown graphically here, and that you can see the size of his army. By the time he gets here, that's Moscow, and that distance is the size of his army. So you can graphically see how his army, as he's marching to Moscow, is thinning and thinning and thinning. And all of these represent dates, and these are specific battles that happened on those dates, right? And then all of this down here, this is the size of his army based on the thickness of the line as he returns back home, okay, with his army. So it's a really good way of kind of capturing all this information, a little bit of text, integrated well, but the chart itself and the diagram is really showing all the information. It's a classic example of some really good chart. Graphical display of information. Alright, so here's a great quote that kind of brings this all together. Graphical excellence is that which gives to the viewer the greatest number of ideas in the shortest time with the least ink in the smallest space. Okay, so not a lot of extra junk, trying to maximize the data-ink ratio, and trying to give as much information as you can in these charts. Here are some tables and some quick rules of thumb with the tables. Use spacing and boxing so that it allows people to be able to read the text easily. Here's an example. You have a really nice kind of heading here that's delineated with spaces that allow you to understand how the data is being presented and based on what row. Okay, it's easily viewable. As you move from title to section to detail, you get more and more information that helps the reader be able to decipher it. And then sometimes, if you have a lot more information, you put it into a note and you allow for even more information to be deciphered, but they have to come down and read it. Here you're really presenting high-level information, and maybe you have a subset of these data here. That's 1950 to 1997, and we're focusing in this column on 1970 to 1977 to see a set of years and the employment growth in the region for just those years versus the total time period that we're studying. Okay? Avoid vertical lines, things like that. These are all rules of thumb with tables. And then, when possible, use ratios. So here we see employment rates for two groups, and then over here we actually see a ratio that helps us compare the two groups. So we can check to see whether we agree with the numbers on these two groups, and then we can look and see the ratio, which gives us even more information as to the importance of the unemployment, for example. Sometimes you want to order these, or and rank them, and it presents them in a nice way that people can quickly get to the bottom of where they want to look for information.